Hi, welcome to ToddFun.com. And well, I got my new Amp Hour t-shirt. I watched the Amp Hour radio show. It's actually a podcast. It's hosted by Dave Jones from the EEVBlog and Chris Gamble, who has Chris Gamble's Analog Life. They get together once a week and make this podcast. It's really nice. They crowdsourced this t-shirt. I was a funder of the crowdsource. It's a really nice t-shirt actually. And if you haven't seen the podcast, I'll put a link below to the Amp Hour. Also have a link at ToddFun.com. And I've watched it it's been over a couple of years now, or listened to it I should say. They did do a video once or twice, but it was pretty poor. So they stick to the radio format, which really works, and they have good hosts and good guests once in a while. So what am I going to do? Well, I got my Amp Hour t-shirt, so I might as well review something that does amps, right? So I'm going to do a quick product review of this multimeter. It's a fairly reasonable multimeter. It runs right now, and I got this one at Newark.com. $54. It is true RMS, and it does it hooks up to a computer. It actually comes with the data cable and the software. So that's pretty promising, and the resolution is decent enough for a workbench, 4,000 counts, and its precision is 0.8% plus I think 2 counts or 3 counts. Not bad for $54. But we'll see in the review how well it actually performs, and we'll go ahead and do the amp measurements when we get to it right away. So, hey, Amp Hour t-shirt, right? I don't normally do product reviews of multimeters, but I had been promising a review of my Fluke 289, and I'm kind of scared because I went through it, and I've used it quite a bit now, and I don't know how I could do a review on this thing and do a lot of justice to it without missing something. So my object of this little kit is to review this and kind of cut my teeth on reviewing at least one multimeter so I can work out the bugs, and maybe you guys can kind of tell me the things I might have missed or should have went over, so that when I do the Fluke, I don't mess it up, because I'd like it to be a fairly reliable review of the features of the Fluke. So this one is just sort of this Tenma is going to be sort of a run through. I've created a 3-page list of things to check when doing a multimeter review. By watching Dave Jones's older multimeter reviews, and more currently MJ Lorton, who has a website and a video blog. His YouTube channel is MJ Lorton, and I'll put a link to his YouTube channel and Dave Jones's, because they're the ones I kind of learned a lot about how to test these meters and how to do a good product review of a multimeter. So I'm just going to try and make as many cuts as I can, hitting each one of these features as quickly as possible. This company, Tenma, it supposedly is in America, but this is definitely made in China. It says that, so it's definitely sourced in China. But I've also noticed that several of these meters, they come in different versions on the side. A lot of UNI-T meters have a lot of the same features. It's so much, they almost have to be cross-sourcing in one way or another. But I'll let the audience kind of figure that out, because you'll just notice just by the layout of the meter that they're cross-sourced in some way or another. I don't know who makes what for who, but there definitely is that. So let's do the unboxing, and then we'll get into each one of those feature tests, and we'll call it a cut. We're at the bench, and we're going to unbox it. I have opened it to read the manual earlier, but that is it, so that I know what I was working with here. This is the 727745. Another model that was close was this one, but it's not true RMS. But this being true RMS, the thing that this kind of is upsetting, that this version does not have auto power off, whereas this version does. And the only reason I can think they would do that is because this has got data cable for a computer, and they just didn't want to fuss with some way of having that also shut down. So it comes with the software. I haven't looked at it yet, but I will try and include that later. This is the manual. It's a really decent manual. It's small. It's not Chinglish at all. It's very much proper English. I went through and noted a few things in it. Indoor use only. This is not rated for any outdoor use. Like I said, it's a 4,000 count meter. But it does do milliamps and microamps, so that makes it good for tech work. It does do frequency and so forth. We'll cover all that shortly. Let's see if I had anything else footnoted in here. Let you take a quick glance. You can stop the video if you want to read any of this. I hope it's focused enough in HD. We'll discuss about these points when we get to the frequency measurements. I found them a bit odd if you're doing hertz and stuff like that. And no auto, when you're in rel mode, you lose your auto ranging, except for it looks like caps. So we'll test that when we're doing caps, if we can auto range under caps, even with a rel mode. And then it's got some specs. I'll let you take a good look at the specs, accuracy specifications. Take a good look at that in case you want to take note of it. And this is not exactly, all this detail is not available directly from their tech specs. But usually they are, but this is the only place I've seen them is in the manual. How to change the battery, and then the fact that this has RS-232, it gives you some of the transmit receive, what the pins are doing, what you can set up like a session with it, with the baud rate that it's using, and start and stop bits parity, so forth. So you got that information if you need it. So yeah, okay. I'll take a look at that in a second. What else do we got? We've got, oops. We got some probes. We'll take a look at that. Really the cheapest looking temperature sensor thing I've ever seen, but it's there for $54. This is RS-232, so if you have USB, you're gonna have to get your own converter, but it is optically isolated. And looks like some handy test clips here, just real short test clips for doing things like capacitors and resistors and stuff. First thing I want to look at is those features, and this is sort of the, if you go to the well, I got mine at newark.com for $54.95, but they're also called Element 14, I believe. So you got DC, they give you the ranges here for DC volts, AC volts, and they get your best accuracy here. Temperature, resistance, capacitance, frequency, duty cycles 0.1 to 99.9, that's pretty high. And the frequency was interesting, you know, 10 hertz up to 10 megahertz. I'll have to test that. But like I said earlier, there's some funniness with that. We have a 10 amp fuse in it for current. We have auto ranging, of course, diode, continuity, true RMS. It's AC, well, what else would it be? Relative mode, which is good. Hold, it's just your standard stupid hold. And then we've got a backlight, low battery indicator, and a 4,000 count. So 9-volt battery is what it's using. It does not say what the battery life expectancy is for this thing, and neither did the manual, so we'll just have to figure that out on our own. It is true RMS, and that's what you want for a tech bench and for tech work. And it's a real reasonable price for this solution, like I say, $54. But I'm going to say yeah, sure. When I got mine, it was $54.95. I've actually checked the site now, and it says $64, and it actually says that's a sale only thing. So they're actually saying their normal price is $90-some, and which would make a little more sense for something that actually is true RMS and has and comes with a ability to hook up and data log to a PC. But it says they got 400 of them, and it's been that way for a couple months. So other than the price creeping up for the sale, it's still pretty reasonable. I must take off this plastic protector. I can't stand looking through that. Oh wow, look at that, I just peeled off the whole thing. I didn't think that was going to come off. That's just its glue down bezel surface, so I don't expect that to be coming up anymore, but it did come up. This is it looks like it's a rubberized product, but it's really not. It's kind of rubbery. It's not really a true plastic, so I'd call it an integrated holster design. It's orange, a really nice colored orange, even kind of a better orange than an Agilent, so I like that. But it's integrated, and let's see how it reels. If I twist it, you can see there's just a little bit of twist in it, but for the most part it's pretty solid. Compared to like a Fluke or something, I'm going to say the Flukes, of course, always have a better feel to the plastic. This is a little cheaper. Of course, the Flukes always have a great range switch, and this range switch is actually pretty reasonable. I don't mind this range switch at all. They did put, if you can see there, they did put a little bit of a ridge here all the way around. If it hits, it's not going to hit the glass, so if it bangs like that, it's going to keep it off the glass a little bit. I would like to see a little bit more of a raised edge around here to protect everything, but that's not really a big deal for a cheap meter. This is the RS-232. It's always on. It never turns off. So that means there's no way to turn it off. So you always have RS-232 blinking away here. So I had no idea how much battery drain that would be, but I don't know. So this is the tilting bail, but it seems like it's okay. When I first picked it up, this bezel would always fall. It doesn't really lock in tight at all. So I wish it would snap in better. And it's not war or anything. It's just that's all you get, So that's annoying. It sits pretty good on the bench. I mean, it doesn't want to tilt or anything too much. So I like that. And when you turn the switch, it definitely doesn't want to tip over. And if you're on the bench, it's not gonna spin. The range switch works fine. It's not gonna rotate on you. So those are a good pass. The range switch is not an on-off switch. This is very, very odd for most meters. Most multimeters, the range switch has a position. Pretty much all of them, I would say, you have a position for off and a position for off. And then if you use it, you have to actually go from an off position to on. This one does not. This one actually has a power on button. You just click it and bam, it's on. That's nice, because then if you're doing, like, say, Celsius all the time, you just turn it off. You don't have to keep cranking on your switch all the time. So I do like that feature. And if you look at the size of these meters, here'd be like my choice of meters that I use frequently. This one's a decent size. It's pretty comparable to a Fluke 17 in size. Certainly nothing like this beast, this Fluke 287. But this Fluke 287 does have the same feature where it's just a single button power on. But of course this thing is going to do, a 10 to 15 second boot up. And this power on is pretty fast. So even though I would say in this camera right about here that looks like this display looks really nice, but for the most part it does not look really nice. From pretty much every angle that I look at these, the Flukes and my other meters have a much better contrast. It's much darker letters and lighter background, whereas this has sort of a dark background with dark letters. And from most angles, most viewing angles, that's not easy to see, though it looks really decent in the camera, I would say. The 727745 does not have auto power off feature at all. In fact, the RS-232 is running all the time, like it says there. You can't turn it off. There's no way to turn it off. And there's this thing. This thing's going to chew through batteries when you forget to turn it off. I very much rely on auto power off for my meters to turn off, because I get distracted from them and go on to doing other things. And not having auto power off is a huge problem for me. So when I'm using this, it'll probably be mostly for data logging. So another good feature that this meter has is the fact that the amps, milliamps, and microamps are separate jacks from where you're doing your voltage, ohms, capacitance, and so forth over here. That's a really nice feature. Looking at the faceplate and the printing, I'm going to say big negative for the prints here. These blueprints, or the blueprinting, so if you come over here and you're like on continuity, diode, ohms, that blueprinting is extremely hard to see in any lighting. I know they want that to match the blue button, but I would have thought it would make a lot more sense visually to have a blue button here for on-off and a yellow button over here for features, so that you could have nice bright yellow printing for your alternate. So you would have a much easier to see contrast. That's very hard to see. See how easy this yellow printing is to see? So that's poor, very poor. But the buttons do feel good. They have good tactile responses to them. It does feel quite nice. A bit recessed for this. If it's just to help it from getting pushed when it's in your bag, possibly. But that's a negative on this one. If you look at the Fluke, that is massively recessed power button right there. It's not going to get bumped too terribly easily. I think that's what they were trying to do with this, is that maybe something wouldn't be able to push it all the way in, but really the recessing, that's on right now, and that recess is not that much. So this could get bumped and turned on and burn through your batteries just being in a bag very, very easily. So that's a big negative for that power button. And then down here they have the printing for it. We got a Cat 4, 600 volts, Cat 3, 1000 volts, 400 milliamps across here, and it's fused. Another thing that they say about this in the manual is that you can't turn this on until you select your position. You have to select your measurement, put your probes in the right ports, then turn it on. It warns several times in the manual not to turn this at all when it's physically on. That you have to turn it off, turn it back on. And we have both AC and DC. If you turn it on, you go right into DC mode, and it's auto ranging. But then if you want AC, you have to hit the blue button, and then it pops up here and says, "Hey, you've got AC." And of course, it always says that it says true RMS, so when you're in AC mode, and you can go back out of that into DC mode. And then you have a continuity, diode, and ohms and capacitance all on one there. You just kind of scroll through it with the blue button. Hertz goes up to 10 megahertz. That's very interesting. Down to 10 hertz. Measures only Celsius. Doesn't do Fahrenheit, which is odd. I mean, if you're programming something, I mean, why not? You know, but I guess not. And this is interesting that you have AC and DC microamps, milliamps, and amps. A different setting for each one, and you can switch between AC and DC with the blue button. But over here you don't have a separate, you know, in a lot of meters you'll see that there's a separate for DC volts and AC volts, and it'll be sometimes even another one like this Fluke 87 has another one for millivolts DC, where this is doing everything with just one button. So it'd be interesting to see what's inside. So the probes that came with the package, I'll pull those out and just see if I like them or not. They're not sharp. If I can get a good close-up on it, that is very not sharp. But it does have this protection on it. I don't think that comes off. It's just got this this shorting protection on it, which makes it hard to do a lot of different types of measurements. You got to get different probes if you want to be able to test with the sides of your probes. They're very hard. They're not very flexible. Certainly not very high quality silicone or anything like that. It looks like it's got strain relief on the end here, but it's not a lot. It's mostly hard all the way up to this little tiny strain relief, so that means this is going to get a lot of bending. It's got the finger guards, and they feel pretty good though, but very plasticky, very cheap. These ends have safety plugs, get rid of those. A little strain relief here, a little bit more, but still not a lot, so you're not going to be yanking these around a lot. Let's see how they feel when I put them in. Yeah, and I'll check this one. Yeah, they all feel good. It's this split kind where they got the banana jack in there just split. They can wear down, but yeah, well, for the price. Cheap probes, don't trust your life to them. So then, like I say, it does do at least temperature measurements. Pretty crude little wire sensor they got at the bottom of that. It looks like some kind of almost something they made themselves, and then they wired it up with a little bit of heat protected cabling. Wow, you can't get cheaper than that. I guess I should plug this in and see what we got. Let's turn this on. Okay, so we're getting 29 degrees Celsius right now. It does have an internal sensor, by the way, without anything plugged in. I'm not thinking that's too terribly accurate. Let's see if... Wow, these are beyond cheap. Wow, that just fell out. I just plugged it in and it fell right out. that is not even going to stay in. That's what's wrong with these splay types. They bend and they don't work. And I've never used this, and this thing isn't even working. See if I can maybe expand it a little bit. And it just broke right there. Okay, so I'm not going to expand it at all. I guess I'm not using this term. Okay, so this is just garbage. Don't even you get this, throw it away. It's useless. Holy cow. Well, I could pull out another temperature sensor, but what the heck. It's going to be something at least. At least that'll do something if you get your own temperature sensor. Oh my. Stuff made in China. People. Well, okay, so we get a couple of little alligator testers. So these are also with the leads. They're pretty cheap, I think. They're soldered on okay, so that's not so bad. These are not the cheap internal ones. These are, well, they're not expensive either, but at least they're not the splayed type. So these do work a lot better. So those are a lot nicer. They're still really cheap, really plasticky, not feeling, but we got a lot better strain relief on these. That's a lot better strain relief design. So these are actually fairly nice for this price of meter. So these are a pass. And the RS-232, it's very much the same as the UNI-T stuff I think I've seen. And so that just plugs in like that. And hey, a lot of times they charge a lot of money for these, so it's really good that it comes with it. And so even though you probably do need an adapter to get to USB, it's here, and we'll test this later. So there's the display working in it's running millivolts right now. It's not easy to see all the time. It's a pass. I mean, for the price, it's a pass for the display for sure. But it's just not as nice as the Flukes. It says it's a 3 updates per second, but I don't really think they got that. I'm not thinking that's 3 times a second. It does have a backlight, but it's really weak. It's on right now. There's green LEDs on either side. It's not noticeable if there's any amount of light at all, so it's not going to help you in slightly dim environments. But if it's dark enough and you can't actually see, you're not going to be able to see your meter at all, almost to the point where this actually helps. I'll turn off the lights and show that it does help in real absolute darkness. And that's a pretty good representation of what it looks like. The camera's not doing much different than what my eye sees. So that looks okay, but it's got to be pretty dark before that's actually noticeable, but it's highly angled. And that's not just the camera. When I do that with my eye, the numbers go away. So let's start off with my PentaRef by VoltageStandard.com. I'll put a link in the show notes to these two. This has got 5 very precise voltage references. I'll show it on my Fluke 289 first, so that you know that these are very accurate, and then we'll go on to showing the meter that we're reviewing, the Tenma. So basically I just turn this on. I'm going to use the same probes that came with the Tenma. And this first one, well, I should probably show, this first one should be 1 volt. Then when I click the button, it should go to 1.2501. And then the next one should be 3.3000, then 5.000, and then 10.0001. Okay? So those are the resolutions we're looking for. Let's see. Now we're starting off with 1 volt, and it's showing it's off by it's just flickering between exactly what this thing is calibrated to. And this is the 1.25 01, and it's exactly 1.2501. It's exactly what's written over here. The next one should be 3.3000. Ooh, and it's just flickering on that, just tripping back and forth. 5 volts should be dead on 5 volts, and this meter's showing just a little bit off on that last count by 2. And the 10 volt range is looking like it's exactly 10 volts. Okay, so we got the PentaRef hooked up to the Tenma, and we got in the volts, it's auto ranging in the volts mode. We got the same alligator clips plugged in, and it should be reading 0.1, and it is reading essentially 0.0998 volts. So it is within spec, but just barely. But if you consider the this range and the fact that it gets plus or minus 3 counts, then you're well within range. Going up to the 1.2501, we're off by 0.01 and a little, but that is within spec. Yes, it is. And 3.3 is what this should be reading, and it is out, but it is within spec. And 5 is absolutely dead on, and 10 is perfectly dead on. So yeah, it's just a tweak out, but it's within its spec at the lower ranges. Okay, the next device, poor man's calibration tool I'm going to use for testing this meter is also from VoltageStandard.com. This is the Dmm Check Plus. It's got resistors racked across the side here, and there's some values noted on them, precision resistors. It also does voltage and current, AC and DC, as well as frequency. So as long as the Tenma is close to these known values for this test device, then it's working fine. Turn it on, and we're on DC. DC should be 5 volts, and that is quite good. So then hit the blue button for AC. This is true RMS, so it should read correctly. Oh, duh, I gotta switch this thing to AC. I gotta switch this to AC and this to AC, because I'm an idiot. Okay, so this should read 4.9999. So it is off by, just a little bit. And yes, 5.03 is within spec. Okay, let's do current, and we should turn it on and see 1 milliamp. Yeah, look at that, 1 milliamp already. I'm gonna switch down to the microamp, and we get 1,000 microamps, which is a milliamp. Very good. Okay, and let's switch it over to AC. Switch this to AC, switch this to AC, and we should still be at 1 milliamp. It's climbing, and now it's stabilized at 1.01 milliamp. Nicely within spec. So the milliamp range on this meter is doing quite fine. Probably go down a range. It went out of AC mode. I got to hit the button to get back into AC. So it should still read right at 1,000 microamps AC. And it does. So those are real good. That passes. Let's test the frequency of measurements, of the hertz. And like I said earlier, I might have put this in the video. If you're over 30 volts and you want to measure frequency, you have to be in the volts range, essentially in the volts AC range here. You can't be at the hertz range. This hertz range is for under 30 volts. If you're under 30 volts RMS, then you're allowed to do that. And then down here they have some more ratings for both voltage and current, what the voltage values can be greater than, and what you can your frequency ranges can be. So yeah, sure, if you're just doing a low voltage frequency, you can probably it'll probably do the 10 megahertz here. But if you're doing any higher voltages, you have to be over in this range. So that's something to be wary of with this. And you can't switch between them like this with the meter on. It says it'll destroy it. And I have heard of UNI-Ts getting destroyed doing that. So this might be just the same thing, and that's why the warning's in the book. But at any rate, let's because this is under 30 volts, we can do it here, and we'll go power on. We'll go to AC with the voltage standard, the Dmm Check Plus, and we're measuring frequency right off at 99.9, and we're supposed to have 99.99, so that is good. We can do duty cycle by pressing this button here, and we should have 50% duty cycle, and we have 4.9. Very fine. Let's hook it up to a frequency generator and see if we can see higher frequencies here. Got this jacked directly into my BK Precision 4007 DDS function generator. I got it set right now to essentially a square wave, and we got it set to hertz, and I have a 1 hertz. That's pretty close to 1 hertz. Now my generator is not super accurate. We're just testing to see if this thing goes up to high frequency counts. So this should be 10 hertz That's not too bad. I'd have to calibrate that with something else because I do know my source isn't that great. This should be 100 hertz, kind of agreeing with the Dmm Check. Let's go up to 1K. That's pretty reasonable. Try and keep the glare off for you. This is 10K, still pretty close. 100K, seems to be holding okay. Let's see, this would be a meg. 6.9, that's it. 7 megs is the highest I go. And 6.99, and that's high. And I know that mine does read a bit high, so that is really good. It does go, at least it goes up to 7 megs, but it says 10, so that is reasonable. So now let's test the resistance. We go to the resistance position and turn it on, and we'll start off with 100K. These are the precision resistors on the bottom. I don't have to have the DMM on for this. It's passive test here. So we'll do the 100K, which per the calibration sheet should be 99.95, and we are getting 99.7, which is within its 1% plus 2 counts. Yes, indeed. Let's go up to the next one, which should be 1K. And it should be 99.99.9, and it is 996, or point in K's is 0.996K. But yes, that's within its 1% plus 2 counts again. And I do notice it's reading very slowly. The ramp is really slow. This is a super slow reader for resistance. Not happy with that. This should be 10K or 10.001, and this is 9.98, which is within its specifications. Always low though, so if there's an adjustment inside, I guess a person might be able to tweak it. And this should be exactly 100K or 100.01K, and we're getting 99.6. Yes, that is within its spec again. So we're good for this. It's slow at reading, but it is within its specifications. I am still in ohm measurements. I'm going to test to see how quick the meter is at ranging from its highest mega ohms to basically a short. It's not too bad. I mean, for this meter, it's a little slow. I got to press pretty hard. Let me press hard and see what happens. If I make good contact, it's much faster. Yeah, it kind of comes down to good contact for this, because these are some cheap tips. If I just lightly press, it takes a lot longer for it to figure out what's going on. So that's a pass. And by the way, when you're measuring voltages, it has a 10 meg input impedance, so that's good. That's what you want. That's continuity. And let's see if it's fast or slow. Is it latched or not? Okay, it's not latched. It's pretty scratchy. I wonder if it's fast or not. I don't know if you can hear this or not. I'll hold it up. Okay, so some genuine fluke probes. These are really nice. Let's see now. Okay, so that's much better. I can hear that fine. It's not latched, but probes make a difference when continuity testing. Nice, clean, shiny probe tips. If I make it very fast, as long as you get better probes, this passes continuity tests with flying colors. Okay, we've got a 390 ohm resistor in there. In the auto ranging, you'll notice it actually goes to K, but I can use the range button, and I can range through all the different ranges, but really it doesn't become of any value until it gets to straight ohms. So I can manually get to ohms without auto ranging, but you have to do that manually. It doesn't want to auto range to something that would actually should know that it can read this in auto range mode, but it doesn't. I go back into auto, and if I want to rel that out, I can hit the rel button. It's nice to have a rel button. When I click rel, the auto range goes away. I'm stuck in K now. So I can switch to a larger resistor. This is a 1K resistor, and it should actually show me the difference, so it should be around 600. And yeah, it's 600K. But I can't change the range once I've reled. That's the problem in some of the other applications. Once you have to manually take the range you want if you know that your difference is going to be something that needs a higher range or a lower range. As soon as I start ranging, it changes, it takes off the rel and goes back to the actual 1K value. So my cheat sheet for checking things now says to check the min-max feature, which I use a lot. And oh, that's going to be missed with this one because there is no min-max option. So that will be sorely missed. But hey, if you can hook up to a computer and just keep taking readings, dumping to the computer, I guess you can go through the, all the mins and maxes yourself. We do have a hold it button. It works with the light at the same time, but if you just hit it once, it just goes into hold mode and it stays there. This isn't the sense hold though, like fluke touch or anything like that, or fluke hold or auto hold or anything like that. It's just you got to hit the button for hold to happen. Okay, I got both these meters jacked up together so that they're both reading the same voltage source off my power supply. They both pretty much agree as far as within their own specs of what the voltage on the power supply is. And we're checking for overshoot. That is, when I pull power and re-add it, does the meter like shoot up to some crazy number like it thinks it's like a lot of volts that aren't even there. Good quality meter will not have overshoot. So first I turn off the power. I just pull the plug. Just pull the plug on it for the power supply. And I'll watch the fluke first, and you'll see there will be no overshoot. It'll go right to the 12.27. Now if you watch, I'll do it again if you watch the Tenma, and it's going to have some pretty bad overshoot. 20 some volts there is what it first thought. So that becomes critical if you're data logging and you have some power turning on and off. It's going to possibly data log like 20 volts, and you're going to think, wow, there was 20 volts there. And it wasn't. It's just the meter's got poor auto ranging, and hence you are going to start seeing bad data collected in your software on your computer. So that's what that's bad for. So let's just set it to a fixed range. So now we won't have auto ranging, and let's see if you can recover from that problem if you know your range. And your data logging. Let's see how that works. 12 goes right to 12. So without the auto ranging, it looks like it's much happier in pulling values. It looked like it was a bit low actually. It started off with about a 10 volt reading. No, it's fine. It might just be how quickly I'm inserting my jack. It went up to, it was like 11, but at least it's not overshooting anymore. So you can get around it with turning on fixed range. So diode check, you turn to that almost impossible to read blue spot, and you hit this button until you see the diode symbol show up on your screen. Sorry for the glare. But it's supposed to measure diodes at 1.48 volts. So let's check that with this, and we will see if it actually does do 1.48 volts, and we should read it over here. Yeah, it looks a tiny bit higher. It looks like it's using 1.51, which might vary with the voltage of the battery supply of this thing. We know we can't push more than 1.5 volts though across whatever we're testing. Okay, so we got a 4007 diode here. We'll go ahead and hook that up in forward mode. And yeah, it's doing fine. It tests it at 0.5, and so it gets a reading and it's testing it. And I have an LED with a lot of meters. You can test them. But because we have 1.5 volts drop and you need more than that to test this LED, you're not going to get a reading and you're not going to light the LED. But I really like on meters that have more voltage for diode testing so that you can actually test your LEDs. Well, let's measure the essentially the burden voltage. That is, I'm just going to measure the resistances that you'll see when you're measuring currents, either microamps, milliamps, or amps. And that voltage, or that resistance is directly related to your burden voltage, and we'll compare that to like what a fluke would have for its resistances on those current measurement ranges. This meter is just used, I'm just using it to show the resistance. So when the Tenma is in the microamp range and you're jacked into the microamps, the actual ohms reading over here on this meter is 100 ohms. And if we switch this to the milliamp range, then the ohms, essentially the shunt resistance of this milliamp range is 1.72 ohms. And if I go to the amp range, the shunt resistance for that current range is 0.07 ohms. And we'll compare that with a fluke, so you'll see how that kind of compares. We'll go over here, and in the microamp range, we still have on this meter about 100 ohms. If we go to the milliamp range, 1.89, just a little bit higher, but not by a lot. And then if we go to the amp range, it's almost the same, 0.07. So really very comparable for current range performance. Capacitance measurements, we have to go to this range setting and turn on and go, got to click this 3 times, and that gets us in nanofarads. Supposedly it can read down to at least 10 picofarads if we get a 1 right here, all the way up to 400 microfarads, which would be just enough to get you by in tech electronics, but it would be better to have a larger range than that capacitance wise for doing general capacitance anywhere else. But if it's just on your tech bench and you're just doing small electronics, it should be fine. I'll hook up each one of these, I'll tell you the reading it should be, and we will see how close it is. I'll be checking each of the capacitors with my Fluke 289. And we'll just say for the argument of this video that this will be the correct readings that we should be getting with this. If this can come close to, including its error percentage, to what the Fluke is reading, then I would say I'm happy with it. That isn't perfect calibration, but it's basically saying it's a usable reading. So I've got a 20 picofarad capacitor hooked up. And I have essentially a reading already of 1 nanofarad with nothing touching. And that's just generally what it's always its offset is, but that's what the rel function's for when you're doing small measurements. So you can rel out that background, and we'll hook this up, and we're getting it says 3 picofarads, and that's really close for a meter like this in this meter caliber, saying it's reading 3 picofarads when it should be 2 picofarads. In fact, I measured this at 28 picofarads, so this is actually not off at all. It's definitely within calibration, or it's definitely within its percent error. I measured this one, it should be 100 nanofarads, and I measured it at 94 with the Fluke. And this is really, it's quite fine at 93 nanofarads. So when you rel out the residual, it's really good. This electrolytic measures 101 microfarads on the Fluke. And now it ranged to microfarads, but it's over limit. And that would make sense, being you see this is 40, 400, 440, and then 100. Though it's kind of not really clear, but that's basically saying 100 microfarads is your limit. So that doesn't really get you by in electronics. You would definitely need something else for measuring your caps, but it would get you with the smaller stuff. So I can't measure the other stuff. We're basically done. There should be no probe sensing of any kind, but let's just see if it beeps or does anything with the screen. No warnings at all. There, you're on your own to not mess up with your probes. Well, I'm going to have to call that part 1 because this is already very long of a review. But like I say, I'm just trying to figure out how to best do all the review items so when I do my Fluke, it's a really good review too. So part 2 is going to be the data logging software. How does it work for data logging? I've already reviewed it and worked with it for a little bit, so I'm already familiar with it. I'm also going to do battery testing to see, just how well it's performing with its batteries and how long its battery life might be. In the low battery indicator, and if anything happens when the battery gets low by using power supply as a source. And then I'm going to tear it down, and we'll just open it up and we'll look at a few of the things, see how some of the protection circuit looks, see how the build quality looks inside, and then there'll be a wrap up at the end of part 2 on how I feel about the meter and if it's worth it, and its shortcomings and its performance that I think is good. So, okay, see you in part 2 if you want to watch that.